Hey guys, it's Damien here, and I'm going to show you guys how to put this helicopter together with the new airframe. Check it out. Alright, so let's build this Goose Guy airframe with a new one-piece frame. So the reason I had to reprint this is because I realized that the tolerance of where the tail boom sits was a little too loose, so I had to tighten up that area a bit, but all in all you need is the one-piece airframe, tail boom with the vertical stabilizer, and the landing gear for the airframe, and then your flight controller, your tail motor, satellite antenna, the bulk of your electronics, and your blades. So the first thing I'm going to show you guys is how to put all this into this, because there is a slight trick to it to be able to make sure it fits properly. It is a slightly tight fit, but you want to take your main motor watt cables and put them between the motor mount and the battery tray. So you feed those through here, just like that. I know this could be a little finicky, but it's not too bad, I promise. After a couple times, it's not that hard to put in. So the goal is to have the motor pushed as far back to the right and have this slightly angled upward so that you could, the goal is to be able to put this through and have the upper bearing block just fit right underneath the anti-rotation bracket here. So I'm going to do my best to show you guys that. So as mentioned before, motor all the way back, and then while you're also doing this, you want to make sure that you're losing the thought of what this is, but the servo link here that goes through the anti-rotation bracket is also aiming towards that slot. So there's a lot of things that you have to be cautious and aware of at the same time, but after a couple of times it's not too bad. So angle the motor back, kind of push down a little bit, make sure that the backside is in between the arms here, and let's start trying to fit this in. Okay, so right there, I was able to angle it up and then just pop it down while having the motor. And here you have some clearance to still move the servo link to fit through the anti-rotation bracket, and then there you have it. It's in there. So that's pretty much the trick to being able to put the electronics into the one-piece airframe. So what we could do now is at least put the screws in. So you pretty much, actually one of the things that I do first is I align the motor with the holes here and mount the motor in first, and then the bearing blocks. I don't think there is that much of a difference which one you do first, but out of habit I'm going to do the motor first. So put that aside. I believe it's a 2mm, so there's 3 screws that you're gonna have to use. And then you want to make sure you're aligning the motor holes just about right. Oh, that's gonna happen to you a few times. I'm doing this with the camera right above, so it's a little different scenario when building, but so the holes are still tight enough where the screws do tend to thread into the plastic, because I wanted a nice tight fit. And then once you align, it's a lot harder with a darker airframe. Usually with a gray airframe, it's not too bad. But you could tell that once you're in the motor, you just kind of keep going until, actually, believe it or not, I'm not even in the motor. So let's back this up a little bit. Alright, so hopefully that does the trick. You definitely also align it from, you can see the screw between the motor mount and the motor to make sure you're aligning the motor. And then hopefully I should be going, yep. So there's that. So you got the first screw in, you got 2 more to go. And once the first screw is in, everything else is pretty much aligned. So I don't really try to worry too much. See if I could, there you go. Worry too much about the alignment of the holes at that point, because they should be aligned after the first screw is into the motor. And thankfully this video might not take as long as the other ones. I think the first time I put a build video for you guys together was with the original Airframe that had multiple pieces, and I believe that was a 2-part video that together was about an hour and a half to do. So that was not fun, but it's out there if you want to still use those one-piece frame pieces. All right, so your motor is screwed in, and now let's put in the screws for the bearing block. All right, so I know that you're probably noticing that I'm not putting any Loctite in. I am constantly testing. Oh, whoops. Don't want to break my landing gear. I'm constantly testing. So for me to Loctite these screws back and forth isn't really worth the hassle. But all right, I gotta make sure I grab the right screw, which I did. So all right, so the screw goes on top here, and for this setup, sometimes you gotta push the whole setup a little bit just to make sure that the screws are aligned, because everything's moving. Usually you put a helicopter together with one piece at a time, so it's a lot easier to put together without having to fidget the actual electronics. But in this case, you have to just move the setup around just to make sure that the holes are aligned, and then you just assemble it. So by now, if you're watching this video, the one-piece airframe, this whole airframe is currently available on Printables and Thingiverse. So if you'd like to download and have your own one-piece airframe, it is absolutely free to download. Goodness, I'm having a real tough time taking these screws out. So they are available to download, and if there are any updates, I will post them there as well. But I've worked tons of hours to make sure that this one-piece airframe doesn't need too many more upgrades to it. It should be pretty finalized, and what's pretty neat is I've actually designed this airframe in a way where the head of the screw is quite flush with the airframe, So if any of my screws start to back out and they surpass the surface of the airframe, then I know the screws are backing out, which of course you don't want that to happen, but that is one way to keep me pretty much making sure that the screws are still screwed in. Here I have to, let's try that again. No, let's try this side. Like I said, I have to push in here and there, but sometimes it's worth doing one side versus the other. I just gotta, there's some flex to the front, flex to the whole unit, so you could just do your best to make sure that the screws fit in. I mean, we are working with plastic here, not metal, so there is some sort of give to make sure that the holes do align. Let's try this one again. I believe this one, oh, this one doesn't want to go in for some reason. Let's see what is wrong here. Oh, I think I have to just push down a tad bit. Not too sure what's going on. There we go. All right, so there you have it. So 1, 2, 3, 4, 5, 6 screws, and you have the entire majority of the airframe pretty much built at this point. So as far as the self-tapping screws, we can put the landing skids on. So here are the new sets of landing skids I'll be testing. I have also increased the length of these legs just so it sits up further off from the ground. And as far, they do print flat, so these skids do print flat. So I have used the lighter to form them into this shape. And so same processes. I'm just skipping a few steps because I know I've covered it in my previous videos. So if you want to see exactly how I put those together, watch my how to build videos on the older model. So since this frame is thicker, I am using slightly longer screws, and these are M1.7 by 6 millimeter screws for these landing gear. Also have to make sure that these holes are aligned. It's a little hard to gauge since this airframe is so dark. I'm hoping I'm aligned. I ran out of gray filament, so I'm using my black filament. All right. That went through. I don't know if you could tell there. You'd see part of the screw on the other side. So once, as mentioned before, once one screw is in, the rest of these holes should be aligned. So let's just put these, oh, It's nice to have a magnetic screwdriver. All right. So these thicker frames are definitely going to benefit the flight characteristics of this helicopter a lot more than the original design. I'm fairly confident that this airframe will be able to handle the aggressive 3D flying that most pilots do without exploding. If you haven't seen my video of flying and doing a TikTok with PLA blades, which I have yet to go back to that project, I'm now using the original blades because the PLA blades were flexible enough where it struck the tail boom and it just boom struck and everything kind of just destroyed itself. All right, so there's that. I did put in new 3M tape because I've reused the original 3M tape that was on the flight controller quite a bit. Now, if you guys are questioning on if the flight controller is put on at least up to this amount, can you put this into the airframe? The answer to that is yes, you can. I've actually had this installed on the one-piece airframe, and I was able to easily install the bearing blocks with the electronics and motor, no problem. But once you get to the point where you have this on there, it will probably not fit. So you want to get your airframe to this point to be able to fit in the center section of the helicopter. So let's see how easily these can be a pain in the butt when it comes to taking them off, and I'm looking for tweezers here. See if I could get it. Oh, there we go. All it takes is just to get started. Awesome. Now one more. And then I also, so if you are curious on what I'm using, it is automotive 3M tape. That's pretty much what this stuff is. It comes in a roll, a thick roll like this. I don't really know how much these cost, but it's not too bad, and they do last you quite a long time. All right, then just mount that on your airframe. Have a nice light push, and then that should stay on there. Careful of not bending the connectors, but yeah. So I have also printed this airframe at 20%. I was originally going to print this at 50%, but I forgot to change the settings, so that would make it heavier. It's already quite strong as it is, but if you want to strengthen some areas of this frame, which the infill is usually around, so this is, the bottom frame is too thin to put infill on, but the motor mounts, the flight controller holder or tray, the arms here, the top airframe, and then your boom block, that's kind of where majority of your infill is, as well as the transition here on the back side. All right, so I'm going to leave this be for the time being. And this is where, so I've discussed about designing a new boom with the I-beam design. I don't know if you see that in the center there's material going down the center of the boom. So the area between this slot and that I-beam design is going to be a little tricky. So this is the first time I'm actually putting these cables through. So if it doesn't work out, I might just try to use a different tail boom. I don't know yet. But let's see how this fits. There's not too much wiggle room here. I'm expecting to possibly get stuck. Yeah, as expected. It's probably trying to feed into one side of the boom versus the other side of the boom. So if this does take a little bit longer, then I might pause the video. I don't want you guys sitting here waiting for me. Otherwise, I might have to redesign the tail boom. So that took a little longer than expected. The cables from the motor pretty much were not able to fit through the boom, and I didn't want to waste too much more time and effort into it. I'll probably do that later, which is another reason why I'm still in the process of trying to figure out a good design for this tail boom. So for the time being, I ended up printing out another tail boom for this helicopter. Same exact design, but this time I have a bar on this side of the body of the helicopter. Mostly because this, when I'm printing, some of the things that I'm trying to figure out is that the tube gets deformed and it's not printing to the shape that I need it to compared to the other side. I don't know if you guys realize the difference, but it definitely makes a difference when it comes to putting it into the tail boom block. So a theory of mine is printing another bar across to make the shape of the tail boom symmetrical on both ends. But anyways, let's put this motor, or the cables for the motor, in. So that shouldn't be that big of an issue. All right. It's taking a little longer than I would like. There we go. Awesome. So now I could feed that through. To the other side. There we go. And here you can tell they pop up. Alright, now I'll probably just, honestly, I don't know why there's heat shrink here. Maybe it's specifically to heat shrink on the backside or on the section here of the tail motor. I'm not too sure, but, or actually I think it's more so to put the, oh, I remember. So the heat shrink is more so to be on this side so that when you're zip tying it to the airframe, you're not crushing these cables too much. But I'm not zip tying them as hard. Okay, so here is what the design will look like. So let's put these screws in. I'll just get all three of them out. Awesome. So the hole dimensions are quite similar as before, so I try to thread these in first. This is actually another design that I haven't even tested yet, similar to the tail boom that I had previously mentioned, so still waiting to see what the results are on assembly as well as flight testing. So I like to have these screws in first before I start assembling the motor. And I haven't mentioned before, I could really tell a difference in the rigidity of this. I'm pretty much pushing it similar to what I had shown in that first video I announced this airframe, where it had quite a bit of flex to it, so that flex has substantially decreased. Alright, so see if I can get it right the first time. Usually I use the screws to align the holes in that motor, and I'm just having a tough time doing that. There we go. That should do the trick. Alright. Perfect. And since I'm constantly tearing this helicopter apart, I am doing my best to not over tighten these screws. But for those of you who are using this as a final design and just a one-time deal, then yeah, I would probably Loctite the screws. But that is the tail section. Now let's put this through here. Feed it through. I usually move the tail motors above the bearing block. I'd like to feed the cables through first before I pull the I think it alright. Let's do that first. We can align the goodness. I'm really having a hard time this round. There we go. Perfect. So that is how that will be set. We can now I'm gonna actually keep these in, and I believe I'm gonna just double check to make sure that these holes are aligned. I believe that's in. Okay, so as far as the set screw on the tail boom block, I have used the same exact set screw, and that is a M1.5 by 4 millimeter screw. So I'm pretty sure that's this one here. So assemble this. I'll just screw that right in. Perfect. Awesome. I could feel that. Yeah, it's not gonna budge. It's pretty much set in. So as far as assembling or tightening up the boom, what I like to try to do, which can be difficult on camera or just in general, is I try to squeeze the bottom section as much as I can, and then screw the M2 by 12 millimeter screws in this block here. So squeeze that, screw those screws in. We'll see how well I can do this on camera. Usually I like to at least get the screw set first, so I'm not angling. Okay, and usually you could always see where your screw is at. Yeah, this is going to be a little difficult. Usually I use my entire palm for this. There you go, it goes right in. And then you should be able to feel a decent stop. There it is. Awesome. That worked out quite nicely. Now you got to do the second side. It definitely looks a little obnoxious on camera, I'm sure, but you gotta take advantage of the mechanics here. I don't know if it's gonna do much of a difference with me still squeezing, even though the first screw is already in. But you know what? Maybe you guys will see the screw go through. Oh, there it goes. And yep, you could feel the wall that it hits, and yeah, there's no way that's going to move anywhere at all. So this is the older boom, a little bit more flexible, so I'm still working on that. Here, I don't know if you could tell, but it doesn't have as much flex with the section going down the boom here, but that'll be a future test and multi-print test, which will probably involve me taking apart this helicopter multiple times. But anyways, all right, so let's feed these cables through. As I've mentioned before, try to label your cables as best as you can. It'll definitely help. I try to wire this helicopter similar to the way it has been wired previously. Man. Just not having a good time putting this helicopter together for you guys. I'm sorry. Usually it's a lot faster. What? Maybe get stronger tweezers. Let's see. Definitely not going to ruin the cables here, but let's try this again. A little all over the place this time, but that's okay. There we go. There we go. Awesome. So pretty much I run this through similar to, I like to move that up. So actually, I think, you know what, I'll probably just zip tie it here. I don't think that's how it was. Yeah, I think it goes above this servo arm, so let's try that. You would think that after so much assembly and disassembly, I would have this down to a T by now, but not very. So I'll probably zip tie them here like that. And then what I have done is I pretty much push all these cables underneath this servo here like that. And then bunch them up right here to the best of my ability. But let's assemble this tail motor. Alright, so the white one goes on first, then this middle one, then this third one. So let's go ahead and do that. I'll have to swap the Phillips tips because these are much finer. Make sure you have your washer on there as well. And this can definitely be quite tricky. So there we go. You don't want to over tighten these either, but you want to make sure they're tight enough where the cable doesn't move too much. I've actually had these screws loosen on me before, so it's just a happy medium. I try to hold the cable when I'm tightening it because it'll just throw it off to the side as well. Awesome. I might just, there we go. Alright, now for the, oh boy. Okay. I believe the screws on either side for both the main motor and tail are exactly the same, but don't quote me on that. I haven't really. I try to keep them separated as best as I can. Awesome. So there's the tail motor. Now I do my best to label these. Let's see if I could read these. I believe that's a 2, 3. All right, so this is 1, and I go left to right as best as I can. So this is 1 right here. Just like that. Okay. There we go. Hold the cable. Oh, I'm holding the wrong way. Like I said, try not to over tighten it, but you can tell that this cable's just not gonna budge. All right, so that's cable 3. I'll have to relabel these cables because the numbers are starting to fade. Okay. The washer on this one was off, so I'm going to do that really quickly. There we go. Alright, now which one was 2? This one was 2. Alright. There we go. And if you guys would like, I can actually post the screwdriver set that I bought for this helicopter, as well as the screws. You probably won't need them, as many of them anymore, since I'm only using a few of them on this helicopter now. That's the downside of buying, and then the upside of 3D printing. You start to improve on your design so much, you just try to reduce the hardware count, which in the end it definitely is quite beneficial. Awesome, we got this last screw. Let's put that off to the side. Oh. Let's try to go sideways here. Did I get it? Yes, I sure did. Awesome. I've actually had this board pop out after both motors were screwed in, and that was definitely not fun. So gently check each screw, making sure that they're all tight in there and there's no chance of them loosening. Awesome. Now I can move on to putting this on. All right. Oh, before I put it on, this already popped off, so let's try to fit this on again. You would think it wouldn't move, but it does. There we go. Much faster than before. Okay. The pins on the inside here have to align with the connectors. I'm not having a good time. I'm trying to make sure that the pins aren't bent, and I put my fingers here because my screws are still in this flight controller. I haven't really taken them out. Come on. Awesome. Now it's officially on. Now, unfortunately, the screw set that I bought is not thin enough, so actually this is a flathead, is not thin enough to be able to fit through these holes on the flight controller, so I have a simple set like this to be able to tighten these screws up as best as I can. And as mentioned before, try not to over tighten these, because if one of these screws would get stripped, then you're kind of SOL. Or worst case scenario, what would end up happening is you would be forced to cut the motor cables and put a connector in between them, which is something that I've mentioned about wanting to do before, but haven't done yet. All right. Wow, that is solid. Okay, now the last step is to make this look pretty. Oh, and of course, don't forget to put the satellite antenna in here. So another area. So the way I've done this before is now I just mount it off to the side here like this with 3M tape on the back side, feed it through, and then plug it in. But so this is, I put a dot here, so that's channel 1. So that's channel 1. Let's see how many dots this one has. Oh, this one has 3. So this is channel 3. There we go. right, now here is channel 2. The one thing I didn't like about when getting this goose guy originally is, well, not something that I really didn't like, but they really assembled this so nicely that the cables were just so tight when it comes to for cable management, and sometimes that's not always good for the cables. But so what I have done, or what I've recently been doing, is, I know it doesn't look pretty. I'll probably figure this out in a sec. But you know what? Maybe I could bunch it up here like that. Because you definitely don't want the servo arm is hitting there. So, but anyways, let me just quickly, you don't need to watch me do cable management. I'll feed this through and then we could be done. Actually, yeah. Feed it through the bottom like that, and then comes out the bottom like so, and then you want to pull it enough where it, I want to make sure the pins, all right, so these are bottom, that this cable ends up going on top. And there's plenty of wiggle room here for your satellite antenna. And then you just pop it up like that. I know it looks very messy here, but pretty much organize these cables, put a zip tie through that area, bunch them up quite nicely, and then there you have it. So here's a quick look of it with it all done. I zip tied it here. I fed the cables from underneath the servo here, so there's some slack to these servo cables, so they're not too tight, but they're bunched up underneath this servo and they won't move. And then you have your servo arm that will not hit anything without any issues. And then your satellite antenna. So there you have it. Besides that, you just gotta put on your blades with your shims, and you have a flying goose guy S2 with a one-piece 3D printed frame. You can use the aluminum boom if you would like. And there you have it. That's all I got for the build for you guys. So if you guys like this type of content, please like and subscribe, and catch you guys in the next one. Thanks for watching.